Hello, everyone, and welcome to this webinar hosted by Danfoss High Pressure Pumps. We are very excited to see that you have decided to join here. I hope or that you think that we are sharing a lot of good stuff about how we can help improve productivity in wood applications. What we are going to talk about is our offerings to the wood industry and how water mist can help you out. First of all, just a little bit of practical information. You are as default muted during the presentation. If you have any questions, please do not hesitate to write them into the Q&A box. Then we would be happy to answer them at the end of the session. Also, please note that this session here will be recorded, and we will be sharing the recording afterwards. So you can go back and listen to it again, or you can share it with a colleague if you like. Right, but let's get started. Today we are three presenters. We have Hannu Salovaara from Finland. He will in a minute be taking you through the different types of applications that we see relevant within the wood industry where water mist can be applied. Then we have at the end of the session a case story from the United States. That will be Pugh that will present this. And then we have myself. My name is Kent. I'm the product manager for the various products that we have that are relevant for wood. And in this case, it would be our high pressure pumps. It would be our high pressure valves, different types of valves. It would be nozzles, and mainly, you can say for this industry here, we are selling our power packs, various types of power packs, which we'll come back to. Now, as I said, we are coming from Danfoss High Pressure Pumps. We are serving a number of different types of applications, from desalination to various kinds of humidification, to firefighting, to gas turbines, and of course wood, what we are going to dive into today. As mentioned, and as you can see depicted here on the lower right here, we are mainly selling different kinds of power packs to wood. This one you see here, called NVC, is our wood concept, and this is one of the key products that we are selling here. Besides this power pack here, we are also selling various other more customized systems. Now, we have served this industry for many years. I think I talked to Hannu a bit earlier, and he said we actually have a jubilee because we have served this industry this year for 20 years. We have a lot of units already installed in the field, and they have all a very long time. So we have had a lot of experience collected already, and we can say that yes, our solutions, they have been proven in the field. We have this NVC power pack, as you see here on the picture. This is a very flexible system. It can be configured in various ways. In the tank, our pump is sitting submerged. You can get various sizes of the pump. You can get the unit with solenoid valves installed right on the frame. If you'd like, you can also get it as a constant speed or with a frequency converter installed. And you can decide whether or not you would like our control system or you have your own that you would connect this to. So there are various ways to work with this. All in all, you get a very reliable high pressure water mist. Now, where can this be used within wood, in the wood industry? There are actually a number of applications where this is relevant. If you're taking sawmills, we have saw blade lubrication, where you can, when you add water mist, it cools the blade, it also cleans the blade, and it means that pitch or resin formation is will be much less, and thereby also the lifetime of the blade is prolonged. Another example is dust binding. I mean, we have typically a very dusty environment, and here by adding this very fine water mist, you can reduce the risk of ignition, and you can at the same time also improve the indoor working environment for human beings. Another application we have is lumber drying in dry kilns and tunnels, where the water mist is helping to secure that the moisture is equally spread in the lumber, and that you will have a more efficient drying process. More information about this in a bit. And finally, one of the newer applications that we have seen is within heat treatment of wood, where instead of adding a lot of chemicals to preserve the wood, you can use a special kind of heat treatment. And there you are also adding moisture in that process to control the humidity when you are drying the lumber. So there are actually a number of good applications where it makes good sense to add water mist. So basically, we have this one solution that this NVC system that can be applied in all of these applications. And if you're a sawmill or in the wood industry, there are a number of different benefits that you will gain by adding this high pressure water mist. For instance, you can increase your productivity, meaning that the throughput you have can be increased. You can produce more lumber. This is because for instance, the lumber drying process is faster, and also what we've seen is that the speed of when you're cutting the tree can be increased when you cool and clean the saw blades. Also, it means that you can reduce your downtime and thereby also prolong your uptime, of course, simply because your saw blades are lasting longer, and also you don't have to carry out as much maintenance on them. If we are looking at lumber drying in particular, you would also be getting a more consistent quality because you have a more consistent distribution of moisture in the wood when you're drying it, and therefore also avoiding a lot of scrap. And the dried wood that you are getting out at the end would also have a higher quality a higher grade, meaning a higher sales price typically. And finally, when we're talking about the dust suppression, as mentioned, you get an improved working environment, and at the same time you also reduce the risk of ignition, as you're simply binding the dust and suppressing it. Right. So that was just a first fly-in to what we can offer here in this industry. Now we will go through the main applications and add a bit more detail, and this will be done by my colleague Hannu. So Hannu, are you ready to take over from here?
Yes, always ready. Yeah, hi. Great. Everybody. I jump into this lumber session. The purpose of lumber drying is to produce dry lumber for construction materials and etc. by drying fresh lumber and using these drying kilns or tunnels for that. This is very, very critical and important production phase, because if the lumber is not dried well, it may cause an unequal shrinkage or cracking inside the material, for example, which makes this lumber much weaker. And in worst cases, you are not able to use that material at all if you have a very bad drying process. In our system, the very fine water droplets produced our systems, they are giving the more equal distribution and faster moisturization in the lumber. It means that the density of the water droplets, it's much thicker, and it's easier for these droplets to reach all lumber surfaces, even they are located inside this lumber stock. In order to prevent damages, it's important that you can control the air humidity all the time during this drying process. There are different technologies for this, like steam. It's a rather old system. It's complicated, needs a lot of energy. Then there's a little bit more simple system, low pressure water mist, where you're typically spraying water on the lumber stock with 5-6 bar, something like this. And then we have this latest system, high pressure water mist, what we have now used last 20 years in many places. Now we can jump to the next slide, please. Right. Here we have some examples, pictures. In the left hand, we have these typical drying kilns and tunnels. I think that all professionals following this sending can recognize these buildings. In the right hand, we have this latest application, this wood heat treatment. It's basically the same like drying kiln. The only difference is that they are using very high temperatures inside, over 200 degrees. And the gray flying steam there above the picture, it's this water mist which are sprayed in this picture into the chamber. This is a demonstrated picture, but it shows very well how it looks, this water mist inside. And of course there are fans which are rotating this water mist when this chamber is in real action. Now we can jump to the next one. This is something, some information of this drying procedure, how it goes in basics. In the left hand we have the high pressure model, and right hand we have this low pressure model. If you follow these different colors, there are red line here in the start of the process, where you are heating up the lumber, and with high pressure systems you can do it much faster, because you can regulate much more exact way this moisturize this humidity level inside the kiln, and it's needed because the temperature is transferred into the lumber much easier if you have the right humidity all the time. That's why this is faster than low pressure, which is not reaching, the big droplets are not reaching all the surfaces of the lumber. Then we have this horizontal lines in the between the red and blue one. This is a drying process. These curves are wet and dry temperatures, and you can see also that the high pressure model is faster than low pressure model. Then we are coming to this blue area, which is called stabilization, where it's important that when you are, it's basically you are cooling down the lumber inside the kiln, and it's vital that you follow the humidity level always, so that the outside surface of the wood is more wet than inside the wood. Otherwise you are cracking the wood. And also it means that when you are able to make this much faster way, it saves time and the quality is much better. So basically, if you are using this high pressure system, it's very effective moisturization, and it takes less time, and the water, this quality of lumber is much better, because you can keep always this humidity level in optimum level. So basically these benefits are between this high and low pressure. It's time and better quality. Now we can change the slide again. So if we are comparing these features, we can see that the capex is in high pressure systems, it's low, especially when we are comparing it against steam. The control of the water amount, it's excellent with our system. We have heard a lot of these positive statements. For example, if you are adding a steam, it's nearly impossible to control. You have to know basically how much you have to add. You can't follow it so easy. Also with low pressure, it's difficult to control, because you are adding so much water in one time, and it takes a long time before you see the results. Ramp rate, it's fast, and also the stabilization time is fast. And of course in lumber business also, and as in other businesses also, time is money. So we can reach a lot of savings by faster process. We can jump to the next. Then we are jumping into this saw blade lubrication. The water mist, very fine water mist, it's excellent for saw blade lubrication, because with this water mist we can keep the saw blade cool, clean from the resin, and also lubricate it, so it gives a much better lifetime for the saw blade, and also helps to keep the saw blade sharp. in the systems where you don't have this kind of system, you have to be more careful with the saw blades. And many times you have these breakages because of the heat caused by resin, and downtime is much higher if you have to stop the product line and change the blades too often. The optimum is that you don't need to change any blade during the shift. Earlier times it was used a lot of these different kind of systems, like low pressure system or oil water mixtures, which are sprayed into the blades. But in these applications, it's very difficult to control the amount of the water or this mixture, and also it doesn't reach the optimum way the saw blade, because in high pressure water mist we are like serving the water mist into the blades, and the airstream is taking this water mist into the process. So basically we are not spraying water into the process, we are just letting it to go into the process. We can jump for the next slide, please. Here we have some examples how it affects inside the saw machine. In this upper blade we have used water, and this lower blade, it has been running without water. So you can see the difference of the pitch. It's of course the upper blade is not absolute clean, but you can see the clear difference by if you are using water or not. It also means that the lifetime is longer, because the blades are clean longer time, the lower power consumption. You can see it because you are using a big motors. We haven't tested in official way, but but we know that it lowers the power consumption. Also, there's no water on the floor, no damping problems or floating problems in the basement of the saw machine. So if you are placing a right size of nozzles, you can't even see that there's a water spraying system inside the saw machine. But results are excellent. You can jump to the next one. In many cases, our customers, they have been able to increase the sawing speed because the blades are not coming hot. The same motors are giving much more better results because of the less friction, and also some applications they are using thinner saw blades because they don't need this extra material for strengthening the saw blade, because the application is taking care that the blade is going smooth through the lumber or stock in this kind of cases. Okay, we can jump to the next one. Here we have an example of the debugging machine. These pictures, they are from the same machine. I don't know if anybody of you know, but it's produced by Valonkone. And in the left side, there we can see that the drum and knives, they are covered by resin, this brown stuff there. And in the right hand, we have this same machine, but with water mist after a couple of hours. We were demonstrating this situation, and that's why we could take these pictures. But you can see that the knives and drum, they are shiny and clean, and even the operator said or mentioned to me that it runs much smoother way, but I can't confirm this, but because the noise was horrible anyway. The placing the nozzles, it's a couple of nozzles needed only, not much water, and this gray stuff you can see between a knife and the drum, it's a water mist. In this application, you are not spraying water against bearings or something, and that's why it's safe for the machine. Some people has also asked how about the rusty problems or this kind of corrosion. But anyway, when you are peeling logs, they are wet anyway, and the process is wet anyway, even without this water. And this is special good system when you are debugging, for example, pine and spruce, because they are producing a lot of dust also, and this also prevents dust. Okay, we can jump into the next. Here we can see one nice picture. It's not snowing, it's dusting, and it means that in this application there's a lot of dust around the area, and it's flying down, and you can see on the floor that it's really harmful. It's really problem for this application. It's harmful for the people, harmful for the machines, and also risk of explosion. In dust suppression, our target is to prevent the dust and we try to catch it where it's coming from. It's much more difficult to catch flying dust if it's in the air far away from the machines, because if you are catching it very close machine, then it's possible to do it very easy way. One big problem, not only for this cleaning, it's only this electrical discharge, which can cause an explosion, and it's a really problem in many places. Also, it's if you are using high pressure water mist for dust suppression, you are getting this cooling effect during the summertime. Also in north areas where we have very dry winter, we can also have an extra this humidization aspect for this area. Also, many people has mentioned to me, for example, when I have been interviewing them, that the atmosphere in general it's rather nice because it's easy to breathe and it's very comfortable environment for them. There are different technologies. For example, how you can take this dust away. The most common so far has been this fan technology, where you are moving a lot of air away from the saw line or inside the building around the machines. But this is a very costly way and needs a lot of space. It's also rather expensive to build up because you need a huge ducts inside the building. But if you are using high pressure system, there are only tiny pipes, 10 or 12 millimeters diameter, nozzles placed in good positions, and tiny unit in some corner. And basically it's easy even if you have very dusty area or machine which is producing a lot of dust. We can even build so-called this dusty or this moisture hood around this area. So close the machine which is producing a lot of dust, there's even more humidity around this machine which is binding the dust. Okay, I think that we are next getting this video. Please don't start yet, Kent. I will, if you follow, we are showing in this video what is the basically affect the big droplet and small droplet when they are touching these flying dust particles, and in this animation we will show how the big droplets they are going down because of the gravity, and small droplets they have better possibility to catch the dust. This is also one thing that I would like to say before this animation, that when you are using 1 liter water, spraying it into the air with low pressure, the surface of the droplets, they are around 30 square meter. But if you are using high pressure, same amount of the water, 1 liter, then you reach the surface with the water droplets, it's close 200 square meter. So you can increase the area of droplets 6-7 times more than by using low pressure. Okay, Kent, please show this animation. So come back to this animation. The water droplets what we are producing, the average size is between 20 and 30 microns, and this flying dust is typically from 5 to 20 microns. So basically they are very, very close the size wise each other, and that's why the effect is much better than if we have, for example, big droplets which are just raining down. And also the density is much higher because we are producing so much more droplets of the same amount of the water. That's why basically we are using less water for the same processes as earlier. Then we have this sorting application. This is typically after every shoreline, where they are just putting the right material to right place, cutting them in the right length. It's also very dusty area because there's a lot of, they are moving this lumber from different places, and it's moving a lot, hitting the places, and that's why the tiny sawmills which is remaining on the surface of the lumber starts to fly. And if you are controlling the dust in this kind of area, for example, by this dust binding, in other words, it's humidifying, it gives a much better environment for the people inside this area. And also, price-wise, it's much more efficient system, use less energy, less space all the benefits are in our side. We have again one slide more comparison of prices? Yes. Basically, if we are comparing fan technology against our high pressure water mist, the equipment cost investment is low. It's only needed to the one unit, pipes, nozzles, and some steering control. Not bigger construction works are needed. Power consumption is very low compared fan system. Many cases we are only 10% of what is needed with fan technology. Also, the footprint is very small compared to vacuum technology, because we have tiny units in some corner and then tiny pipes there and there. So all these big ducts are not not needed in these systems. So I think this was a short information of these different applications. There are many more these applications what we have, but we try to keep this presentation short and sharp. Thank you.
Right, Hannu. Thank you very much for that. So I hope that you could see, based on what Hannu has informed about, that there are a lot of good benefits by adding high pressure water mist to all these applications within Sawmills. If we just have a look on what kind of products we are dealing with, then we have listed some of them here. The main type of product would be our power packs. It would be our wood concept here as one, and as mentioned, we also have other more customized units, but this is the key product. Inside the blue tank here, we have our pump sitting. We are also producing that pump ourselves. It could be either the PHT or the PAH, depending on what type of water quality we're talking about, whether it's a technical water / DI water, or whether it's tap water. Besides this, we have a number of different valves. We have solenoid valves, on-off valves. They can either be supplied separately, or then they can be also mounted on the frame of the power pack. What you see here is our actually a dedicated power pack valve. It includes both a solenoid valve and a relief valve to make sure that when you reach a certain pressure in your system, a certain set level, then the relief valve will open and relieve the excess water and pressure back to the tank, and thereby recirculate the flow. It's also possible to recirculate all the water if you don't want to. If you have an application where your application need water, and then you need to stop it, and then short time after you need water again, then you can also recirculate pressure free back to the tank by using this solenoid valve here. Besides this, we also have a range of nozzles for this type of application. If we have a closer look on our NVC unit here, as mentioned, it's built around a tank. Inside the tank, our pump is sitting. The tank acts as a buffer, and it also provides cooling for any recirculated flow. Plus, it's actually the ideal environment for our pump being submerged here in the tank. So it's kind of a shelter for the tank. It also means that when we're talking about lifetime and service, we see that in many cases, service is, or the interval in between service is very long. Typically, we even see up to 20,000 hours before service is required. Of course, it's important to have the right conditions here and the right filtration also. But otherwise, up to 20,000 hours is what we've seen within this type of application here. Then we have our power pack valve that I just mentioned sitting here. This is recirculating any excess flow back to the tank that is not required by the application. And another function here is that you can circulate it back to the tank pressure free if your application is not needing the flow. An advantage here is that you can use this in a constant speed mode, where the motor is running at a certain speed without VFD, and then you just use the power pack valve to recirculate water. But as mentioned in the beginning, it's of course also an option to use a frequency converter to control the speed of the motor and thereby also the pump speed. As Hannu has mentioned before, this is a very small footprint to cover a very wide area in a production, both in terms of the power pack itself, but also in terms of the pipings needed to be installed. So thereby this also means that this is not only for new applications, for new installations, but it can also be retrofitted or upgraded into already existing applications. I saw we also had a question about this from one of you listening in here. So that's thank you very much for that. But it is possible to do both new installations and retrofitting or upgrading existing applications. If we take the next slide here, so basically we have one concept here that can be configured to whatever need you may have, and it can fit into a lot of different applications. It's very robust and very reliable. It has high uptime, and as mentioned, a very long service intervals. Also, when you're using high pressure water mist, you get a highly effective system that can cover a very wide area with just a very limited amount of water. As Hannu said, we're talking about a factor of 6 or 7 times the area that you can cover with the same amount of water compared to a low pressure system. Then it's also easy to fit into tight spaces, making it also ideal for upgrade and retrofitting cases in existing applications. And finally, as mentioned, we have been in this business for 20 years now, and so we have a long experience and a product here, a solution here that is proven in the field. Right. I think that with that being said, let's jump to one of the cases that we have that we'd like to present for you, and that would be my colleague Rob that would take us through this case story here. Rob, are you
yes.
Ready?
Yes, I'm with you guys. I think we have a little delay, so I hope you guys can hear me okay. So I'm going to be going over our case story that we did earlier this year with our customer, Sawmill MD. And in this particular application, we actually had an end user that was moving a kiln from the Northeast to Arizona. I only mention that because Kent pointed out that our technology is applicable to existing applications as well as new applications. So in this case, the end user, originally the kiln was the dry kiln was being used with a boiler. And in the new application in Arizona, they didn't have a boiler, so they had to look at alternate ways to humidify the lumber. So we did have some challenges with this application, one being the actual species of wood. So ponderosa pine is, they call it a appearance grade. So it's very important that the lumber, once it's dried, is of good quality. The point being that as it states here, when it's susceptible to staining. So when you get a quality downgrade, the bottom line to the sawmill deteriorates. So the other challenge we had was the kiln was now in Arizona, which you can get, I would say, fairly large temperature swings between the daytime and the nighttime. So again, when you're drying wood, you're really trying to control humidity, airflow, and temperature. And so when the ambient environment is changing, that makes controlling the kiln a little more difficult. So the last challenge we had was the actual size of the kiln. In this application, excuse me, the customer had two kilns that they moved, and both were really large. The largest was 100,000 cubic feet, which is about 3,000 cubic meters of volume. So the application actually required 900 gallons of water. So it was again very large kilns for the application. So do next slide there, Ken.
Yep.
So the solution, we ended up going with an HPU, a single HPU. The beauty of the solution was that we could basically humidify both kilns with one HPU. So the end user was very pleased about that. We ended up using a tap water pump, our high pressure pH 63. Again, so because we could humidify both kilns with one pump, we had one pump, one motor, one VFD for speed control. And then that pump was actually feeding 10 separate valves that were obviously sending the manifolds into each kiln. So we had about 1,300, capable of 1,300 gallons per hour. So very large flow, and we can actually, that pump's capable of, I want to say like 29 gallons a minute. And in that frame size of pump, we can actually get up to about 39 gallons a minute. So a lot of capability there. Next slide. Okay. So this is the power unit. Again, very, very compact. You can see the pump motor package in the back. We've got our 10 valves up front, and it is a turnkey solution. So really the only thing that the end user, the customer, has to do is run the piping and then integrate their control panel to our control panel. So with this particular application, the end user was extremely happy. Again, when we're talking sawmill, dry kiln applications, it's reducing scrap really, and also increasing the quality of the lumber. So our grades of lumber was very high and the scrap rate was very low. And we were able to do that because of the precise humidity control that our solution offered. So we also talk about CapEx and OpEx, obviously in any project, whether it's a retrofit like this or a new piece of equipment. CapEx is a concern, and as Hannu went over, our technology is very low on the CapEx end, especially compared to a boiler for dry cone humidification. So the other is OpEx. Again, comparing a boiler to our technology, it's not even in the same ballpark. Our customer estimated that our technology on the humidification side was actually about 90% more energy efficient than a boiler. So all in all, it was a great project. The customer was extremely happy. They're actually looking at retrofitting more of their fleet and are also trying to specify us when they have to buy a new kiln for future operations. So we're looking forward to doing more with them. Yeah. So that's it.
Great. Thanks,
Thanks,
Ron.
guys.
Thank you very much for walking us through this great case. We actually come to an end now, but I see that we have a few questions that we could go through. The first one, is it possible to add on or upgrade an existing sawmill factory with this high pressure water mist system, or is it only for new plants? It is possible, definitely, to make an upgrade as we just said.
Could I answer that one, Ken?
Both. Yeah. Go ahead.
So in North America, we have a very large and established mill industry in lumber. So I think all of our applications to date have been retrofit applications. So because Kent mentioned our packages can be catered and engineered to specific applications, it's really up to the end user to decide how to apply the product and what application would best benefit them. But it's absolutely, you can apply it anywhere in an existing mill. So
right. Thanks, Rob. Then we have another question. Do I have to shut down my operation during installation, or can I run my business in parallel?
Can I take some responsibility of this? If you are installing, for example, inside the kiln, of course, it's not possible to do during the process. But typically, these installation works, they are made everything what is outside of the kiln can be done beforehand. And the last part inside the kiln you can do when you are taking the lumber out, and before you are putting a new in between that time. It doesn't take so long time to make these pipings ready because they are basically rather simple to install. But of course they can be some hours delay because it's needed to, for example, if the pipes are located in let's say very high level, then you need some trapeze or that you can go up and make the installation there. But basically the answer is yes, you can do it while producing or drying lumber. But short break is maybe needed. Hopefully this helps.
Right. Thanks, Hannu. Then there is a question about, is it possible to have a trial or test equipment with some basic features just to check and see the performance of the system before we decide? Yeah. So I would say we do have some options there to offer such a unit. But if that is the case and you would be interested in this, then please reach out to us so we can discuss this a bit more in details what you need. But the very short answer.
Some cases, some our resellers or system builders, they have rented a unit. It's also possible to, I don't know where this question is coming from, but for example, we have some clients who can also tell a lot of details. So of course we are doing everything possible to show the benefits of these systems. Just take contact to us, please.
Yeah, exactly. And the final question I have so far is what quality should the water have? And I think this goes, this is regarding filtration. So we have filtration or filters already sitting on our units. Our pumps, they need 10 micron absolute filtration, and that is already sitting on the power packs that we are selling. And
I think,
and as mentioned. Yes, sorry.
Sorry, I was just going to say, I think it's my understanding in some applications they may treat the water somehow to adjust the pH level, but other than that, I don't think there's any other requirement.
No, I think that's also part of second part of that question. But you're right. Yeah.
Yeah, because in that case we need to use technical water pumps.
Exactly. So we have both options depending on the water type. We have the PAH pumps for normal tap water, and then we have the PHT for the technical water or treated water. Let me see. Then there's a question. Danfoss recommends to inspect pH pumps after 8,000 hours. Did you say 20,000 or 12,000? Under what conditions? You're right. The standard recommendation is to inspect the pump after 8,000 hours. That's still true. So what I said was just that within this area here, when you're talking about wood and when we are talking about our power packs, we have just seen that typically 20,000 hours is it's capable of handling that in between pump inspections, and the conditions here is that the filtration is in place. Besides this, the pump is sitting in an ideal place and can run for a very long time. Anything to add, gentlemen?
No, I would just agree with that. I think our customers typically they're getting 4 to 5 years without pump inspection, but to Kent's point, as long as you keep the water clean and you're using good filtration from us, that's absolute rated, you should get long life out of the pumps and the units. So.
Right. Thanks, Rob. So I do not have any more questions coming in. Well, I have one now. It says, how often do you need to change your filters?
Are you taking Kent that or me?
Would you like to comment on that, any of you?
Yeah, it depends the water quality. We know the applications where the customers has used river water, for example, then we absolutely recommend to use pre-filtration. And basically we are recommend to change that at least once a year. We have this sensors, pressure sensors there, which indicates when you have to change a filter. But basically, if you are using drinking water, for example, it's not going to happen too often. It's rather, let's say, once a year. Some people are changing after 2 months. Some people after 2 years. It's very wide range of the service interval for filtration, but it's important to change it when you get the indication that it's going to block this filter.
Right. Thanks, Hannu. So I think we're actually even a little bit over time. But if you have any more questions, please feel free to reach out to any of us also after this session here. We'd be happy to help you out. With that being said, I would say thank you very much for attending. As mentioned in the beginning, there will be a recording shared with you, so you can watch it again, or you can share it with a colleague if you'd like to. But from our side, thank you very much, and I hope you got a lot of good information. Goodbye.
Bye-bye.